Yeah, hello students. So let us look into the another few very small topics, right? In our the last that is the fourth module. So in the last class we have seen minimum description length principle. So today we are going to look into the concept called as naive Bias classifier. That's a very simple concept. Now already we know Bias theorem, right? Bias theorem, or it's also called as naive Bias theorem. So what is that Bias theorem says? Probability of H given D, right? Probability of H given D is equal to probability of D, that is our data sample, given H multiplied with the probability of A, right, divided by probability of D, divided by probability of D. So this is what Bayes theorem already we have discussed in our the previous topic. So now we are going to look into the naive Bayes classifier. So now this is one of the very practically learning method method what we are going to use. So this is a learning method where we are trying to use the naive Bayes theorem and naive Bayes classifier. So what it says is that whenever a new instance comes, we have trained our model with respect to the training data set, and with the help of this how we can classify this particular new data sample into which classification it belongs to. And this particular method has proven in many of the examples that it has got a very good performance, just like our neural network condition tree algorithm. Okay, so now let us look how we are going to define this problem. Now in this naive Bayes classifier applies to a learning task where each instance X is described by a conjunction of attribute values. So we are going to consider an instance X of our training example, and we know that every instance X has got certain attributes and it is described by conjunction of attribute values. Like say in our previous model we had taken one of the general examples in this entire machine learning, that is whether a particular person can play tennis or not. So depending on certain attributes, we had some outlook, we had the temperature, the sky. So we had certain 6 attributes. Based on that attributes, whether he can play the tennis or not, right? So now if you consider one training instance which has got certain attribute values, and where the target function, now what is this f of x? F of x is the target function. So in that particular example, whether he can play tennis or not, now if you consider your target function f, it has got two values. One is s, he can play the tennis, or no, he cannot play the tennis. Now can take any one or any value from set of finite value v. So v, now v has got two values. What is that? One is either yes or no. There might be certain example. In some example you may be having more than two values also, like say for example some low, high, mid. So depend upon the values, what output values what we are having. So where each instance, so how we are going to define this naive Bayes classifier, so it is a learning task where each instance X is described by conjunction of attribute values. Conjunction, the conjunction is if air temperature is this much, if sky is like this, if outlook is like this, and right, and then whether he can play tennis or not, right? So described by conjunction of attribute values, and where target function f of x can take any value from set of finite set output. So here in this case we have two. One is yes, he can play the tennis, or no, he cannot play the tennis. Clear? Now a set of training examples of the target function is provided. So we have got some set of training examples. We train our model based on the training examples. A new instance is present. Now when a new instance comes, we are going to describe by the tuple of attribute values. Now a new instance, how we are going to describe? It has got some attributes value a1, a2, etc. up to an. Now the learner is asked to predict the target value. Now he has to predict, now for this new instance, which has this attribute value, whether he can play tennis or whether he cannot play tennis. This is what you have to predict. So the learner is asked to predict the target value or the classification, right? So if you are able to predict the target value, yes, he can play tennis, so you are classifying him in that group. He cannot play the tennis, you are going to classify in the another group. This is what we are supposed to do. Now we are going to apply the Bayesian approach. Now the Bayesian approach to classify the new instance is to assign the most probable target value. You are going to assign the most probable target value V map. So in the previous section, so we were calling H map, right? Most a priori hypothesis, right? Now there we are considering hypothesis, so we denoted it as H. Now we are denoting it as V. Why V? We are looking into the output. So we are looking into that output, yes or no, whether you can play tennis or not. So the most probable target value V map, V map, given the attributes value A1 to AN that describe the instance. Now how we can write this particular equation? We can say V map is equal to arg map, right? Argument maximum of for all Vj belonging to V. Now what is this Vj for all Vj when you are telling? So now in that playing tennis or not, now we have two. One is what? V yes, that means whether you can play tennis or not. Another one is V no, whether you cannot play the tennis. Only two are there, right? So we are going to find the probability of Vj. That means for the given set of for these attributes for new instance, what is the probability that we have to calculate the probability for L y, that is yes. What is the probability that this attribute value you are going to predict it as yes? What is the next is what is the probability that for this attribute value, so it is going to give no, right? Suppose say that if, for example, if the probability yes is 80%, means obviously 20% will be the no. So you have to calculate, or you have to calculate depending upon all the what is that attribute values you are going to have. So this is how we are going to rewrite this equation. Now V map is equal to arg max. Now if you have a probability of yes is 75% and the probability of no is 25%, then obviously you can classify that new instance can belong to this class with respect to the Navy Bias classifier. Now this equation we are going to rewrite this equation by using Bias theorem. So we can say V map is equal to arg map. So arg max Vj belonging to V, probability of Vj given that A1 A2 this, so we can write it as probability of A1 A2 etc. up to AN given Vj multiplied with probability of Vj divided with probability of A1 A2 etc. up to AN. So this we have rewritten this equation by applying our Bias theorem. Now we will simplify this. Now if you look into this equation, the denominator what it is telling, probability of occurrence of attributes, right? Probability of A1, A2, A3 etc. up to AN. Now this probability is not influenced, or it is not going to influence or anything about this whether he can play tennis or not. So that means when you are saying for all Vj belonging to capital V, that is the target output, this probability of A1, A2 is not dependent on this Vj. That is why we can treat this denominator as a constant and we can ignore this. So when you ignore this denominator, we can write it as V map equal to arg max of Vj belonging to capital V, probability of A1, A2 etc. up to AN given Vj. That means for this given attribute value, so you are going to find the probability with respect to yes, then you are going to find the probability with respect to no and multiply it with the probability of yes, right, and probability of no. So this is what the equation we are going to get, right? So now let us see here. Now we could attempt to estimate the two terms. So we have got two terms in our equation. This is our first term and this is our second term. Now this term is very easy, right? Probability of yes. How do you find? So you are given, say for example, this is what, when we are taking example, it will be very clear for us. Now we'll go to this example. Already we have seen this example in our previous modules also. Now you have got 14 data instances. It has got certain attribute. Now if you call this D1, D2, D4 as your capital X, right? So and this outlook, temperature, humidity, wind, now all these attributes A1, A2, A3, A4. Now when you consider the output V, now this is play tennis, capital V. Now what are the values it is having? So if you look here, it has only two values. One is yes and the other one is no, right? Now this you can call it as Vj. What is this J? J goes from 1 to 2. So one is yes, the second one is no, Now it is very clear for us, right? So now you have got so many attributes are there. Now if you want to find the probability of yes, probability of no, because in our equation we have got probability of, now we'll come back to this equation. So here I can see one term is probability of Vj. What is this Vj? Probability of yes or probability of no. It is very easy. How you can find probability of yes or probability of no? By counting. You are given 14 data samples. Out of 14 data samples, how many yes are there? How many no are there? Right? You can easily find the probability. Now if you look at the two terms in our above equation based on our training example, now probability of Vj is very simple. We can calculate as we told by counting the frequency in which each target value Vi occurs in our training data set. How many times yes is coming, how many times no is coming. Easily you can find the probability. Right? So now we'll come to the first term. The naive Bias classifier is based on simplifying assumptions that the attribute values are conditionally independent given the target value. Now in our naive Bias classifier, here also we are going to make one assumption. Now what is that assumption? It says that all the attributes values like outlook, temperature, all those things what we have seen. Now these attribute values are conditionally independent. Right? One attribute value is independent of another. It doesn't depends on that. So independent on what? Now target value. So now these attribute values are completely independent on your target value. There is no dependency between yes or no target value and your set of all attributes. Now that is the assumption what we are going to make. So you have to remember this carefully. What is the main assumption of our naive Bias classifier? The attribute values are conditionally independent to our target value. With this assumption, now the probability of observing the conjunction, right? So if you take your first term, the probability you are going to find A1, A2, A3, A2, etc. Right? So now the probability of observing this conjunction of these attribute value will be just the product of the probability for individual attributes. It is nothing but product of probability of individual attributes. Why? Because conditionally independent. So we can rewrite this probability of A1, A2, etc. up to An given Vj as product of I. Depends on how many variable sets we are having. So product of I or product of probability of Ai given Vj. You take the first attribute A1 and Vj. Vj means two things, yes and no. So for yes, you find how many, what is the probability. For no, what is the probability, and you have to find the product. So this is how we are going to look into our first term. So now we try to substitute that. So how we can substitute that in our previous equation? Now when you substitute this is your first term, right? First term you are going to substitute product. Where? Here. Now this becomes our product term, right? This and now we try to rewrite this equation. Now if you look, now we rewrite that particular equation as R max of Vj belonging to V, P of Vj, this was the first term, multiplied with, that is the second term in that equation, so P of Vj, probability of Vj, multiplied with the product of probability of Ai given Vj. So now this expression, now we call it as VNB. What is this NB? NB means naive Bias classifier. Till previous equation we were calling it as VMAP. Now we are going to call it as VNB. So this VNB denotes the target value output by naive Bias classifier. Right? Now this will be more clear when we take up the example. So now to summarize our naive Bias learning method, which involves a learning step in which various probability of Vj and probability of Ai given Vj are estimated. You are going to find out the probability of these two things based on our training data set. And set of these estimates correspond to the learned hypothesis. This is how our learning hypothesis, or which we said the learning machine is going to do. So now this hypothesis is then used to classify our new instance. So now what is that? How we are going to classify the new instance? What is the equation for naive Bayes classifier? VNB is equal to argmax. Which one is, after finding this entire term, which is maximum, you are going to find. So based on that, you try to classify. Argmax of Vj belonging to capital V, probability of Vj into product of probability of Ai given Vj for all the attribute value I. Right? So now one interesting difference between our naive Bayes learning method and other learning method is that there is no explicit search through the space of hypothesis. Now here we are not going to explicitly search all the hypotheses. We are assuming, or we are assigning the probability depending upon our attribute value. Right, that is the main difference here. Now instead the hypothesis is formed without searching. We, in the previous method, we are taking set of all hypotheses, and each hypothesis we are going to consider, and we were finding the maximum a posterior hypothesis and all. Here we are not doing like that, right? So now let us take a simple example and we'll see how we are going to apply this naive Bayes classifier. Now this is our training data set. Now we are going to take the same training data set. We are to classify whether a person is going to play, can he play tennis or not, right? So we have got 14 data example. Now outlook. Now we know that outlook takes 3 values: sunny, overcast, rain; temperature, hot, mild and cold; humidity attribute, it takes high, normal, 2 values; and wind attribute takes weak, strong, right, 2 attributes. Now this is the same data set we are going to use. Now let us see here. Now here we are going to use naive Bayes classifier and the training data from the table to classify for a novel instance. Now we are given a new instance. Now in this we have got 14 training set. 14 training examples are given, right? The model will learn on these 14 training examples. Now you are given a new training example. Now let us say this is our 15th example. Now what is that new training example or new training data set we are having? Outlook is equal to sunny, temperature is cool, humidity is high, wind is strong, right? Only this much, because we don't have what is the output now here. Target is not there. Whereas in this 14 example, target is there. This is our target, yes or no. Whereas here we don't have the target. Now you have to predict by applying naive Bayes classifier. You have supposed to classify this new training example whether yes or no. Whether play tennis, whether he can play tennis or no based on this training example. Right? Now our task is to predict the target value yes or no for the target concept, that is play tennis, for this new instance. Now we are going to apply the equation. Now listen carefully, it's very simple. Now we'll write the equation. V of NB is equal to argmax of Vj belonging to capital V. Now capital V, what are the 2 values the target can take, yes or no, right? Sometimes it might be 3 also, depends upon our data point. In this example only 2. So what we are writing here, what is the capital V? Either yes or no. Probability of Vj, product of I, probability of Ai given Vj. Right? Now this is equal to argmax of Vj belonging to yes or no, probability of Vj, right, multiplied with the product. Now you see what is Ai, how many variables are there? Outlook is equal to sunny, right? So we will take probability of outlook is equal to sunny given Vj, right? Here is there given Vj multiplied with the next attribute A2. What is A2? Temperature is equal to Q, multiplied with probability of temperature is equal to cool given Vj multiplied with the third attribute humidity, probability of humidity equal to high, and multiplied with given Vj, and probability of wind equal to strong given Vj. I think it is very clear, right? So 4, 1, see here 1, 2, 3 and 4 attributes are there. Now you are going to find the probability of each attribute with respect to Vj. With respect to Vj means Vj has got 2. One is yes and one is no. Clear? One is yes and one is no, and you are going to find this entire product. That means multiplied with probability of Vj. Now you see, now you observe, listen carefully, how many probabilities you have to find out. First is you have to find this term, first term. In first term, how many probabilities you are going to get? Probability of yes, probability of no. So here you get two probabilities, right? You are going to calculate two probabilities. Now here, probability of output equal to sun given Vj. What is Vj now? Here again two are there, right? So now first you will take the first yes. You will take yes. Find out probability of outlook equal to sunny when yes. Find out probability of temperature equal to cool at when given yes. Similarly, find out probability of humidity equal to high given yes. Probability of wind equal to strong given yes. That means 4 probabilities you are going to calculate, right? Clear? This is first. Now second, you are going to take what will be the Vj value. First yes is over, next is no. So for no, now you are going to find probability of outlook equal to sunny given no, temperature equal to cool given no, humidity equal to high given no, wind equal to strong given no. That means again 4. So here what happened? 4, 4, 8 plus 2, totally 10 probabilities you are going to calculate. I think it is very clear now, right? So now this is our example. So now let us see how we are going to calculate. So the same thing is told here. So you are going to calculate 10 probability. Now first is probability of this, we will see this term, probability of Vj. How we are going to calculate? That means we are going to calculate two probabilities, right? So probability of Vj. What is this Vj? What is Vj? Platonist. V is Platonist, right? J, two values are there, yes and no. So first probability of Platonist equal to yes. How we are going to calculate? Is equal to 9 by 14. How you got 9 by 14? You look into your training example. Totally how many training examples are there? 14 training examples are there. And we are first you are going to count for yes, probability of yes. You see in the last column how many yes are there. So when you count here 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally 9 yes are there for 14 training examples. So probability of play tennis equal to yes is equal to 9 divided by 14, that is 0.64. Clear? Now probability of play tennis equal to no. So in that table you calculate how many times no is appearing, 5 times. So 9 plus 5, 14. So 5 times no is coming out of 14. So 5 by 14 is 0.36 is the probability of no. So now two probabilities we have calculated. Clear? Now we will go to the second term. Now as an example we will take one particular attribute, wind equal to strong. See, we have 4 attributes here, right? So we have 4 attributes: outlook equal to sunny, temperature equal to cool, humidity equal to high, wind equal to strong. Now we will take the first one or any one on this. So wind is equal to strong, right? So we are going to take wind equal to strong. So probability of wind equal to strong given Vj, right? First one is given yes, play tennis equal to yes. Second one is same, wind equal to strong for no. So now in our data example, so first we will see here wind equal to strong and output target value is yes. How many are there? Right? We'll see. Now wind equal to strong. Now this is our only these two things we have to see. So wind equal to strong. You see here 1, 2, 3, 4, 5 and 6. So totally 6 are there, right? So totally 6 wind equal to strong is there. Now probability of strong given yes is equal to 3 divided by 9, right? 3 divided by 9. So now for this strong, if you see here, this strong here is no, here is no, here is S is 1, S is 2 and S is 3. So 3 times S is coming here, right? So 3 times S is coming. So now we are going to say 3 divided by 9. So 3 divided by 9. So 3 by 9 is 0.33. Clear? So this is what we are saying. We are saying that for attribute value wind equal to, where it went, yeah, so for wind is equal to strong, right? So now you see here, so now probability of wind equal to strong when you are going to play tennis, right? Tennis equal to S is equal to 3 divided by 9. So now let us see once again. Let me go to the cursor. Yeah. So strong, wind equal to strong we are looking, and also what is the target? Target should be S. So you strong is no, you need not count. Here also no. So now you are going to count this 1, this is 2 and this is 3. Strong is no. So now how many times you are going to have strong with S? 3 times, right? So now we say that probability of wind equal to strong when play tennis equal to S is equal to 3 divided by 9. Now how 9 comes? We have 14 training examples, right? We have 14 training examples. Now you see, out of this 14, how many times S is coming? 9 times S is coming, and no is coming 5 times. So S is coming 9 times only. So 3 divided by 9. So 3 divided by 9, not, you don't take it as 14. Now because we are looking for S, target value S. So wind equal to strong with the target value S is equal to 3 divided by 9. Now similarly, next probability of wind equal to strong for play tennis equal to no. Is equal to no. Is it how much you are going to have? 3 again. Now let us see here. Wind equal to strong and output is no. So here you have got 1 strong and output is no. 2 strong and output is equal to no. How many? Total 3, right? And how many times no is coming in our out of 14 data set? 5 times, right? Here we have seen, right? No comes 5 times. So 3 divided by 5, which is equal to 0.06. Now 0.33, 0.6, right? Now this we have done for one attribute, one training attribute. Like this we have to do for 4 remaining 3 also. If we do like this, if we calculate like this, so then using these probability estimate and similarly estimate for the remaining all probability values. So now you see here clearly already probability for S you have got, that is 0.64. Now if you take that 0.64 multiplied with, this is for S you are doing, right? So 0.64 into, for one variable wind equal to strong for S is how much you got? 0.33. 0.33, right? So this is for S and this product, right? So now if you do like that, that is probability of S, which is 0.64, and probability of sunny given S, you calculate. Probability of cool given S, probability of high given S, you calculate. And last one, probability of strong given S. Probability of strong, that is wind equal to strong given S, here we have calculated 0.33. Now this value is 0.33. Got it now? Similarly, calculate probability of high, right, for S. So that means you are going to calculate for humidity. So humidity high for S. So high, and you see here no is there, here no is there, high yes 1 time, high is yes 2 time, high is yes 3 time. So 3 divided by, right, 3 divided by how many times high is coming here, or how many times yes is there in your example? 9 times. So again that is 3 divided by 9. 3 divided by 9 only for this one high. Like that for remaining 4 attributes you calculate the probabilities. And when you calculate that probability and multiply with probability of yes, which is 0.64, you are going to get 0.0053. Similarly, take the second one, no. What is probability of no? So probability of no is 0.36. You take 0.36 multiplied with, now in the same manner. So for outlook equal to sunny with respect to no now. You have to look for no. And cool equal to no, high given no, and strong given no. So strong given no, here we have found. Count how many times for wind equal to strong, and output target is no 3, and totally how many no's? 3 by 5, 0.6. Now similarly high, count for high when output target is no. You count how many are there, divided by 5. You will get this fellow. Like this, when you find the probability of this, you are going to get 0.0206. Now you are going to apply this algorithm, or you are going to apply this argmax, right? Argmax, out of these two values, which is maximum, that will be your classification. That means your new training example. Now here, which is having more probability, is very clear that, so the second one is having maximum value. So we can predict now, say that for this given new training example, that is, thus the Navy Bias Classifier assigns the target value play tennis equal to new for the new training example based on the probability estimates learned from the training data. Now this is how the Navy Bias Classifier is been working, right? So now it is very simple when you look into the example. So try to understand this thing. So this was a very simple concept about our Navy bias. Clear? Now try to understand, try to look into these examples and try to understand. So in the next concept we will go into Bayesian network, right? So in the till now we are saying that attributes are conditionally independent, right? But in reality, in certain examples, you may have some attributes which might be dependent also, right? Now if that comes, how to handle that? So we are going to discuss that in another very small and a very easy topic, which is called as the Bayesian network, right? So you try to read this particular concept carefully and look into the example. Clear? Thank you very much.